and I am Dr. Alperucci.
Welcome. Today I will show how to use Python with the simple example of Snell's law.
In today's video you will see the solution is quite simple and it can be written in a closed form. In the next video we'll make a step forward and study a case where you need to solve numerical equation. In particular we will deal with the solution of Snell law in an isotropic material.
If you like this video, please do subscribe and click the bell icon for notification. So let us start. For our programming in Python, the basic packages which we need for scientific computing are Numpy, SciPy and Matplotlib. These are the basic things you will almost use all the time. And you can find the documentation about all these things online at scipy.org, and for Matplotlib also there is the whole documentation. Matplotlib is for plotting and the name sounds similar to MATLAB because it was intentional, because they wanted all the people who were working in MATLAB to move slowly to Python, and they kept all the names similar to MATLAB. And similarly you can find Numpy. This is the basic package. It is numerical Python and you have all these functionalities. And yes, so also you have these functions for integration, optimization, interpolation and all this thing. And scipy.io is for loading your input data and analyzing your data, and all these functions are in the SciPy package. So let's see how to start our Python. So I have already started Python with Spider new instance. So as I was saying, I will always be using Spider interface. So I have already 2 Spider instance running. So if you want a new, so usually you just type Spider and your Spider will launch. So I wanted 2. If you want 2 instances, just type Spider new instance like this. Okay, so then let's see. So I have already written the codes, but let's start with for convenience. So let's start with a new file. So as I was saying, the basic thing you need is a Numpy. So usually you import it like import Numpy as np. So this is how everyone does it. So you are importing. So now you can see that it's saying, okay, I have not used it for anything. It's okay. So you can just go on and save. So I will just save like talk to save. So now you are ready to start using Numpy. So you have to first before going further, I would just simply, let's say if you're coming from MATLAB, you need to understand some changes between MATLAB and Python. So let me define something like AA is equal to np dot arrange. It already shows you, if you type, it already shows which function you want to choose. So there is the arrange, so you can just click, and then the arguments. So you can, it's easy to learn also. It shows you what you need to type: start, stop, and the number of step. And if you want, you can also give a data type. So for now we will just say, let's say I want to make 0 to 10 in steps of 2, or better, let's say 0.1, because I can do it like this. So save, run. It has run. So let's see what is our output. So the output is, it has made 0 to 9.9. So it does not make until 10 but until 9.9, because the indexing starts from 0 and then it goes until 1 less 9.9. Okay, so maybe it's let's see. So if you say check you can just type the variable you typed, so AA, and you can check its shape like this, and it is of the size 100. So you can check what is AA of 0. So the indexing starts from 0, whereas in MATLAB the indexing starts from 1. So you will have A of 0, which is 0, okay, the first element. But you don't have A of 100, you have A of 99, which is your last element. So these things are a little bit confusing when you come from MATLAB, but you will learn easily. Just use check the shape, just check the size of the whatever variable you are creating. So you can, so this is also a tip. So if you want to know the size of the variable you just created, you just say either a shape, or you can also take, I think, a size, which is 100. And here you get, with shape you get the tuple form, but here you get 100, like the size. So this is one of the first things. And now I will just define something BB, which is equal to range. So this thing comes directly, this is directly a Python function, it's not coming from Numpy. So range, I can say 0 to 10 in the steps of 1. So let me see what happens. So let's see what is BB. So it gives you like this, and you check what are the elements. BB of 0, which is 0, and BB of 9, so, and which should be 9, and you can check the shape. Okay, this does not have a shape because this is not an array. Okay, so here you cannot use it. So if you use the inherent function BB range 0 to 10 in steps of 1, if you're using this function, let's see, you can increment only as integers. So if you want to increment in 0.1, it will not work. So let's run this selection. You see, this does not work. So you need integer values for this increment. So this is one of the things. Okay, and next, let's see, if you want to define square, the syntax is like this. So let's write square A equals, so if I want to say 2 into 2, I have to write, and let's say 4, 2 into 4, I have to, 2 raised to 4. So I have to write like this. Like this is the syntax. So if you run, okay, this is not square, I raised to 4. So anyway, run selection. So it is 2 raised to 4. So what is square A? Is 16. Okay, so this is the syntax. You don't write like in MATLAB 2 raised to 4. Okay, this is the syntax. You have to write 2 times multiplication star. Okay, yes. So now let's see the Snell's law. It's simple, we all know it. It gives you the relationship between the incident angle and refracted angle when light passes through two different media. So for this I'm using the Jupyter notebook. I have already started here somewhere. Let me see. Yeah, so the Jupyter notebook I started here. This one, I guess. Yeah, so if you remember from last time, you can just start it with typing Jupyter notebook. Where is it? Let me see. Shutting down. Okay, this one, Jupyter notebook. You just type it into your terminal, and a new page, web page will start on your default web browser. So here it will go to home, and you can go to you can see all your folders in your computer, and it will go there. So and you can create a new file. So I created this file just to show you how it is. So you can type it here. So okay, usually I do not want to use this, but it's a good way to document what you are doing. But I prefer to use the spider directly, because this I don't like. Anyway, if you want to document the things you have been doing, you can use this Jupyter notebook. So what you have to do is, you will get a cell and you go here and it shows you what kind of cell you want. So you can choose code or markdown. So I use markdown, and then if you use this hash, you get heading, and you can write Snell Descartes law or whatever. And then if you want to have LaTeX commands, you can put it inside $2. If you put it inside $2, you will get it in its own line, like in the normal LaTeX when you type. So then you can just run this cell alone, or you can use Control Enter to run this, and you get the output. I mean, this looks more like Mathematica. If you're familiar to it, it looks like Mathematica, and it stores what you're doing. So you have your Snell's law, which is, so if you have two medium with isotropic medium with refractive index n1 and n2, and if the light is incident from the medium n1 to medium n2, and the incident angle is θ1 and the refracted angle is θ2, you have the relation n1 sine θ1 equals n2 sine θ2. So you can always find these angles θ1 or θ2 by finding the arc sine of this function. So this is the figure, just to show like this. So there is one medium n1, there is the another medium n2. θ1 and θ2 are the incident and refracted angle. You always measure the angle from the normal to the interface. So this green line. And yeah, so we are going to illustrate this example through the example of total internal reflection. So what does it mean? Your refractive index n1 is greater than refractive index n2. Okay, so you know that if at certain angle, which is the critical angle, there won't be any transmission and all the light will be reflected back to the medium, and which is your total internal reflection. Okay, so so how do we do this in Python? I mean, this is a simple example. So this is just to introduce you to Python. So also this figure you can make however you want, but I also made this using Python, and I will show in the end how to make this figure using Python. I mean, it's quite simple. I mean, okay, you don't have to use Python or to you make your figures always, but just know that you can do it. Okay, so we also have the critical angle here. So let's go back to our spider window like this. So I can just delete this. I don't care about this. I can just delete. So I will import Numpy as NP, and I will also import matplotlib. Okay, I always forget what are the, yeah, matplotlib, pyplot, as plt, plut, they call it as plut. So you can import. So these are the basic things. I will also, okay, I will not, usually whatever you want to import, you just include it on the header of your script file. Okay, you can also import in the middle, it does not matter, but it's a good practice to import whatever you want. So anyway, for now, I will just import only numpy as np and matplotlib.pyplot as plut. So I can save. So I'm not going to type, I'll just copy paste the first things which I want to do. So and I will go one by one into the function. So what I have defined here is, I defined the refractive index of the two material. Refractive index n1 as 1.5 n2 equals 1. This is what you have to do. It's simple. You don't have to say anything about the data type or whatever. So it understands. So it's quite simple, this defining. You can do as you saw before also. So for critical angle, I already wrote the formula. So if you see, if I type np dot arc sine, it will tell me what are the things you need to put. So it will always advise you what is the syntax, what functions are available, and so on. So usually if you type npa, it's supposed to tell you what are the functions. Yeah, if you press tab, it will show all the available functions. In case you don't remember the name, you can just check it up, like what you want to add, like this. So okay, so here, okay, I'll just delete. It's arc sine, that is inverse of the sine. Just open the brackets and you write the formula in the simple way. So I mean, there's nothing particular about it. The syntax is very easy. So here, what did I do? So angles are usually in radians, so I converted into degrees. Let's see. Yeah. And then this is np pi. So if you want the function pi, you can also load here, but you can just write np pi and you get your pi value here. Okay. Similarly, I define input angles. So the input angles are, I say input incident angle from 0 to 90 degree. So what is this function, linspace? So this is a new function which I define. So what does it do? np dot linspace. So what it creates is equally spaced values. So it so linspace. So it shows what you need, start, stop, and how many number of points you need between the start and the stop value. Okay, so here the stop value is included in if you use linspace. If you were using np arrange, the stop value is not included. Okay, so now what you have to do is you can say 0 to 10 and you want 10 values. So what do you get? If you say, I'll just show here, Control V, home, AA equals. So what is AA? So 0 to 10, the 10 values. Okay, so it's 0, 1, 2, 3, 4, 5, 6, and I don't know, so the precision is also here. Anyway, so it is, so here I have taken 0 to 90 with 200. I need 200 values from 0 to 90. Okay, and this is in degrees, so I convert into radians, np pi by 180. Okay, so these are the so I just put the calculated the critical angle, I just put the input angle, and the refractive angle, not refractive, angle of refraction, like np arc sine, just refer to the formula. And I wrote refractive index of n1 into np sine. See, another function, np sine. It's also coming from the Numpy package, so np sine. And then np sine of your input angle. Input angle, now remember, it is an array. It is an array, and then I divide. I mean, I just write the formula, so it's quite simple. You don't have to take care. So it already took this array here, and it will calculate on each element of this array refractive angle. And similarly, I wrote another angle, angle of refraction. So this I wrote from, if you come from medium 2 to medium 1, I mean, you can do that, right? You can also do that. So you wrote your formula like this, now you can just plot it. So for plot, what do you want to do? So this is the important thing. So you already loaded from matplotlib the function as plot. So this plot has everything. Plot, they call it plot. So plot has all the things. So just press tab and it will show you what. No, you need something like it will show you what you can do, plot whatever. So you can add figure if it's in F, figure legend, everything. So I mean all the functions are there, so you will see as and when you need it. So plot figure. So what I gave is I just gave it a name, but in fact you can specify a lot of other things like face color, at what DPI you want to save. These are the default values, like none, face color is none. So you can specify these values if you want, but for now I'm not doing. I just gave it a title, refracted angle. So I can plot. For plot, it's again, you take plot.plot. So it's similar to MATLAB. So you just have to know where it is. So you can just refer to the examples and you can see from the documentations of matplotlib. So here input angle, it's already an array. I converted it into degrees, and refracted angle again, which is calculated from here, I converted into degrees. And then I said I want to label the file. So what you have to do is label, and I said high index because it's saying that the input is going from high index to the low index. And here similarly I marked low index because I want to say that the light is traveling from low index to high index. So again refracted. And then to show this plot legend, you write plot legend. Okay, and you can just run. So it will come in a new window like this, and you can increase all the size and stuff of these figures. So usually today I will not show how to increase the font size and everything, but it's simple, you can just add them. So here what has been plotted. So blue is from high index. So this is your critical angle, because at critical angle your refracted angle becomes 90 degree, right? So after this you cannot calculate, so it does not give you any values. So it's like this. And if you come from the low index side, 0 to 90, no problem, but the refracted angle would be maximum at the 40 point. I don't remember the actual value. We can check actually because we calculated critical angle value, which is 41.8 degree. Okay, so this is just to show how you can plot different kind of data. I mean what you want. So here you just plotted it. You can do you calculated the refracted angle from both sides of incidence and you plotted it. But you see, if I did the same thing here in the Python notebook, Jupyter notebook, so here it shows I have an error, because it does not calculate above the critical angle, because the value of the absolute value of sine goes more than 1, so it cannot calculate the inverse, right? So for here I just use something like import warnings, and I suppress the warning and I still let it run. So if you check, because it will give you NaN values, so if you check here, it already your refracted angle, you see the last values above the critical angle are NaN. So you have the values here, and above the critical angle it's not able to calculate. Here it's still, you can plot and everything, even though it's an error, it can understand it. But here in the in the Jupyter notebook not, so I had to suppress this, ignore this warning, and I said anyway plot it. Okay, so this is the simple way of doing things, simplest way you can do. Now let's do how to write it as a function. Okay, so for the function, what you want to do is you just want to give refractive index. You want to write a function. You know the refractive index of the two media, and then you want to calculate the angle of refraction if you know the refractive index of two media. Okay, so you also want to calculate. You want to calculate the total internal reflection. So you are assuming that the light is going from high index to low index. So let's see how we can write a simple function. Okay, so for this I can just copy here, Control C, because I don't want to type, and I'll go here. I'll just put here. So, and then let's see what we do. So the syntax for functions is this: you write def, then you write the function name, and then you put all the arguments you need, like whatever arguments, if you want to give refractive index or number of points. I mean, these are, you can give whatever, I mean, with all the arguments you want to give, and then remember colon, enter. So now you see there is a indentation, right? So you cannot start from here. You should respect the indentation. So this is the syntax. So now you can say give all the conditions you want to give. You say okay, refractive index, or let's say epsilon equals square of or refractive. Okay, I will use underscore index square. So you are just calculating square of the refractive index, and then your output would be, if you want, you can just say return is epsilon. I mean, this is the simple way to write the function. Okay, so here I have written this function, refracted angle. I have given two inputs, refractive index of medium 1, refractive index of medium 2. Okay, so we don't know which is greater than the other, so I introduce this if else also in this here. So if else, all these things, every time you go into one of these things, you have to go make an indent. Okay, I mean, all these functions, there should be an indent, it should be indented. So you here one indent. So now for if, I say if refractive index of medium is greater than refractive index medium 2, again colon at the end, and then indentation, and then I calculate the critical angle, which is like this, medium 2 by medium 1, and then I say refractive index high is refractive index medium 1, that is larger if it is, and refractive index low as like this. Okay, so the input angle, I again define input angle as like NP lin space 0 to critical angle, and 20 I need 20 points between 0 and critical angle. Okay, so else I say if critical angle else, so else means anything, any other condition. So in this case the else would be refractive index of medium 2 is greater than refractive index of medium 1. So I say else these are the conditions. I calculate the critical angle and say these are these things. Okay, now I say angle of refraction is, and again from the Numpy, arc sine inverse of refractive index high, sine of the input angle, and divided by the refractive index low. Okay, and then I say return angle of refraction, input angle, and the critical angle. So this is a function. So how do you call this function? So I will just run this like this. So now I would say, to call this function, what I would say is that I need 3 outputs. So I will say, I would write simply, I'm just writing simply refraction, input, and critical. You can say, you can write whatever variable you want to write, equals, call the function you want to call refracted angle, and then give the variables it needs. So I will just write 1 and 1.3, let's say, and then I can enter. So now I can see what is ref. It is an array, all the angles it calculated, and the size of ref would be 20, right? 20, because in linspace we said we need 20 points. Okay, so now input angle also would be from 0 to critical angle. So let's see what is the critical angle. It is in radians, so I just convert into degrees. So 50.28 is your critical angle, right? So now this is how you write your function. So you just have to give your input and you can calculate all these things. Okay, so this is what I did here. So I said refractive angle, input angle, and let's say critical angle, because you can write whatever you want. I wrongly wrote Brewster, so it's critical angle. So it's refracted angle, and I can give refractive index, the 2 inputs, and then I say let's plot what happens. So I plot input angle versus angle of refraction. So let's see. Okay, the function is already defined, so I just need to run this. Let's see our plot. So it plotted on top of it. So let's close this, because I did not define a new figure. You can define a new figure here if you want, like plot.figure, because if you don't define a new figure, it will plot on top of the original figure, whatever figure was created first. Okay, oops. So you can just define something like angle of refraction, this is a string, okay, angle of refraction function with respect to function. Okay, so I just plot it like this, run selection or current line. You see, so these are with I have only 20 points, so there is this discontinuity. So if I want to plot only the points, I would say I want to plot with O. I will plot like this, run selection or current line, with this dots. So it has plotted these the data with dots. Okay, like this. So you can just say how you want to plot, give the line style or whatever. So and these are the basic things. So now let's see what else we can do. Let's check. So this is how to write functions. So if you have any doubts, do write in the comment, and we are happy to reply. Now I introduce SciPy. So for SciPy has these functions of interpolation. It has a lot of functions. So now I'm interested in the interpolation function, because you see I have these only 20 data points, but I want my curve to be smooth, and I want to make it, let's say, with 100 data points or 200 data points. So I can interpolate from whatever I have, right? So what you have to do is from SciPy you import interpolate function. Okay, so this you can already write on top of your script. From SciPy import interpolate, and let's see what you can do with it. So here this is a little bit difficult to understand but not complicated, but let's see. I'll just put it here, the data, like so if you want to comment something in here, you can use Control 1, or just then if you use Control 1, that line will be commented. That's Control 1. Okay, to uncomment again Control 1. So, or just type the hash symbol. Okay, and this is for interpolation. So commenting this, if you write these comments in between, this helps you track what you are doing instead of just all the codes, the bits of code. If you comment it, you know what you are doing. Okay, so I just write interpolation and I just pasted this. So this is the same. It's taking the angles from the function, okay, from the refracted angle, and then what does it do? What am I doing here? So I have the refracted angle. From above I know that I will have 20 data points, right? So then I define a function to I define a variable saying function to interpolate, and I call interpolate dot interp 1D, that is interpolate in one dimension, 1D interpolation, and I give what are the values which I have, the data with small number of points, which is input angle and the refractive angle, and then I say what kind of interpolation I want to give. So I say kind is equal to cubic. You have a lot of methods, so you can check the example for interpolate the documentation for interpolate.interp 1D, and you will see. So you have cubic, linear, and all those quadratic, and all those different methods. You can check what are those methods. So I just use cubic here, and then I say input angle to interpolate. I define something. So now I have my x not interpolated, I have my y data not interpolated y data. Now I want it on a finer, larger grid of from 0 to the critical angle, but in steps of 0.001. Okay, so it means so I used NP arrange here. Okay, so it will not have the last critical angle here, so always it's better to use NP linspace. So this is just to show that you can use. Okay, so from here I would, or you can just say +1 or plus 0.001 here, so then it will have the last value, right? So I'm saying I created another grid, another 1D grid, 1D with more number of points, and then I say now I calculate the angle of refraction in this interpolated grid. So I will have to call this function f int, right? So I say f int of input angle interpolated. So what it gives is this function takes this input angle, interpolated input angle, and gives you the angle of refraction interpolated here. Okay, this is one method. So here also you have many methods for interpolation. So there is another function called interpolated univariate spline. Okay, so this there is you can choose whatever method you want. So there is another method. So this works like this. So again I define the function, a variable. I say this is the function which this is the method, this is the function, and I give it the required variables input it needs. So it needs input angle, and it needs angle of refraction without interpolation, but here I don't have to give the kind because I already said I want the spline interpolation, right? This is a different method. And similarly, like before, you calculate the interpolated data, you just give the function and then you give the angle to be the interpolated angle. So now I can just say plot. I just name the figure as before, and then I plot you see here different, if you know MATLAB, it's similar to MATLAB. You give the X, Y, you give how you want it to plot, then you give another set of data, and then you can give as many set of data, or you can simply use different plot, plot.plot, okay, different lines. But here you can write in a single plot.plot all the variables you want to plot, okay. So let's see how it is. I will just run this part and see. Yeah, name interpolate is not defined. Why? See this error. Why? If you remember that I'm just running the small cells, I did not load this. Even though I copy pasted it, I did not load this, right? So I would just run this selection, okay. And now let's see if it works again. Okay, it works. Let's see what is the output. It won't, I don't know how clear it is. Maybe it's better in the earlier figure I created. So, okay. So there are 3 sets of data here, right? I think I will go with the other figure itself so that I can show it like this. So there are 3 sets of data here. One is this on top. So one is your not interpolated data, which is input angle and refracted angle, which is plotted as square dots, circles, okay. So dots, so these blue dots are your not interpolated data. Now you made the interpolation in 2 different ways. One is in angle of refraction interpolated, ref interpolated, and another is just fuse. Okay, I did not name anything. Okay, so then you see one is in dashed and one has, I don't know how clear it is. There is a dashed line and a straight line. So the data are on top of each other. So anyway, what you got is that you got lot of different values, more values than 20. So let's check what is the size of ref underscore interpolated dot shape. You have 730 values. So you got data, so you interpolated the data and you got data points for where you would not have values originally. So these things you can, because if you're making some measurement, maybe you're making 10 measurements and you want to have a smoother curve, you interpolate. You do it usually in all the way, I don't know, usually you do it. So in Python you can do this like this if you have a 1D data. Okay, yes. So now let's see one more thing. This I can just close it. Now, so earlier I wrote all my input angle and thing as an array, right? So now let's see how to write loops. So some loops are good, sometimes they are not, but sometimes you need the loop. So let's say I want to calculate the refractive index, the critical angle for different refractive indices, okay? So let's say I define refractive index n1 like an Numpy array. See, this is a new thing you are learning. So Numpy array, so inside it's again just a list. So I gave a list inside. Between the square brackets it's a list, but I changed it to an Numpy array. So I can index it and I can call it, right? So I gave different refractive index values like 1, 1.2, 1.3, whatever, 2, 3, 10, whatever. So, and then I said refractive index of n2 is just 1. Now I said I want to calculate the critical angle for, I can just copy it. And do it here, right? This is for loops, huh? So then I said, look, what I want to do is I want to calculate the critical angle for different refractive indices. So what I have to do a 4. So I would the formula is the same, critical angle NP arc sine refractive index of N2, the lower, divided by the higher, and then I convert it into degrees, right? So if I so what I have to do is I want to take every time one of the values from this matrix, this array, refractive index. So what, for writing a 4, the syntax is like this. You say 4, then you define a variable ref, which you call in ref n1. So it is ref in ref n1, and then you end it with the semicolon, colon operator like this, and then you say, you call the ref here, okay? Whatever the thing you want to vary, you call it here. So I also want to save at every 4 step. I want to save it in a counter. So remember, our counter starts with 0. The first index is 0. So I start count is equal to -1 because the first index is always 0. This you have to always remember. So then I add count is equal to count plus 1, and then the critical angle for this count. So if you write this different from MATLAB, what you have to do is you have to always define critical angle before, or the size of the critical angle. Otherwise you cannot write a counter for it. You have to give the size of it. So what I do here is I write critical angle is NP zeros, that is, it's creating a set of zeros with the size of ref n1. Okay, so what does it do? Let's see. Run selection. Now I will see critical underscore angle angle dot shape is 7. The shape is 7, which is the, and all the values would be 0, right? Right, all the values are 0, and the size is 7. So at every count it will update the values. So let's run it and see. You see, you have this thing. So you have 7 points, so I can plot with circles. Line with circle. Run selection of current line. So it's here. You see, you can see that the data is so now you have only 7 points. So you don't have any data between 3 and 10, right? So what you can do now is, okay, this is more a homework for you. What you have to do is interpolate this data to, let's say, 200 points. So you need, now you have 7 data points. Interpolate it to 200 data points, okay? And then what you can do, and write it as a function. So what you have to do is find the critical angle, write this function, this thing as a function, and you also have to interpolate. You can do however you want. So these are the things you have to do: interpolate the data and write as a function. And this is what we covered today. So if you have any doubts, write on the comments and we will answer. And if you want this IPython notebook, just in case, I can put a link to it. Now I did not put, but if you want, just let me know in the comments and I can put a link to it. If you have any other doubt, do let me know and in the comments, and we will write. If something is not clear, also let us know. So do this homework, try to do this homework. If you have any problem, let us know. This you cannot just watch, you will not and learn. You have to practice it. So these are simple methods to learn. So do this, write a function and interpolate the data. Okay, so next video we will see about an isotropic medium and how to apply Snell's law in an anisotropic medium. So if you have any comments, let us know. If you like the video, do subscribe. Okay, see you until the next video.